Hello everyone, welcome. This is a new lecture in your course, Linux for Absolute Beginners by Avionics. My name is Ahmed, and in this section, we are going to discuss how to deal with files in Linux. Now, we have mentioned before that files have a very important role in Linux. In Linux and Unix in general, everything is a file. This is a famous saying in the Linux world that everything is a file, from device files like networks, hard disks, even USB drives or CD-ROM drives, to kernel files that hold the libraries that run the system and system calls, to the configuration files and settings, to the startup scripts, to the user files. Everything in Linux is handled some way or another through a file. So for that reason, it is very important that you know the role of files and know how to deal with files on a Linux system. Now, before we start, we have to distinguish between two main types of files. In Linux, we have system files and user files. Let's see the difference. When you create a document using write, for example, this document is not as critical to the system as the /etc/password file, for example, because this file contains important data about all the users in the system. So tampering with this file is a lot more dangerous and more destructive to the system than tampering with a document that you have created. Tampering with /etc/password file will affect all the users of the system and may bring the whole system down, while changing the content of the document that you have created, although it might be harmful, but this harm will not exceed you as the creator or even a few users that work on this document, but not the system as a whole and not all the users that are on the system. For that reason, those critical files that are called system files are protected from accidental or intentional altering. On the other hand, files created by users that are called user files, these are documents, spreadsheets, image files, audio files, or any file that you created using one of the commands that we have discussed in a previous section. Those are considered users files, and they can be modified or deleted by their owners or by whoever has the permission to do so. The important distinction here is that system files affect the system as a whole. It affects all the users on the system, while user files affect only their creators or people who have permission to work with those files. Now, in order to clarify the difference even more, let's have examples of system files. Startup scripts, those are files that launch services, or sometimes called daemons, when the OS boots. For example, the system may be a web server, and this web server needs to be started whenever the system boots. In order to start the web server, there is a script that is used to launch this daemon, and daemon is another name for service. In Windows, for example, you have the concept of services, which is a program that runs in the background and provides some sort of functionality to users. In Linux, this is called a daemon. Okay, so a web server or a web service is a daemon that has to start in the background. When the system boots, it gets started using a startup script, and this startup script, because it affects the daemon on the system, and this daemon affects all the users logged in to the system or the system as a whole, so it is considered a system file, and all startup scripts in general are considered of type system files. The second example is program files, and these are the files that are used by the installed software. For example, the binary file that is used to launch the program, the image files or the icons that are used by the program when it is running, the configuration files or the settings files. All these are also called system files because they affect how the program behaves, and accordingly they affect the whole system, so they are considered of type system files. Also, system configuration files, and these are files that contain important settings that define how the system works. For example, when you want to configure the network on a Linux system, as we are going to see in detail later in this course, you open a text file in some location and you edit this file, adding the IP address of the server, the gateway, whether or not it is going to have an IP address assigned to it automatically. All these settings affect the system as a whole. So this configuration file is of type system files, and it is protected from accidental altering by regular users. Also, files that contain important data and what's called database files. A very prominent example of these is the /etc/password file that we have just mentioned a few moments ago. This file holds all the user information their usernames, their user IDs, and other information about users on the system. Changing the contents of this file, as we said, can either prevent users from logging into the system or bring the system as a whole down. So it is, of course, considered one of the system files. And finally, event logging files. The operating system in general logs information about its behavior and what instance happened while it was working, or right before it crashed, or the moment it started up, and so on. It keeps on logging this information in specific files that are called system log files. These files, of course, should be protected from accidental or intentional changing by regular users, because, for example, somebody may do some harm to the system, and if he or she wants to wipe out their fingerprints or their footprints from the system, they have to change this file. Let's say, for example, delete the information that reveals what they did to the system or who did what to the system at which time. Of course, this information may be invaluable for system administrators when they want to diagnose something wrong that happened to the system, especially if that change was intentional. So event logging files are also an example of system files. But how can you work with these files? Now, we said that these files are protected from users, but if I prevented all the users from changing these files or from working with these files, then those files will remain the same and you will not be able to change any setting in the system. For that reason, system files can be manipulated by using an account that has what's called the root privilege. The root privilege, or the root user in Linux, is the system administrator. This is the account with the maximum possible power on the system. This account can do anything. It can change any file. It can delete any file. It can do virtually anything to the system. So it is very dangerous when this user account gets compromised. So it must be protected by the maximum possible security procedures. And one of the best practices is that you never log in with this account directly to the system. So if you have a computer and you own the OS on this computer, so effectively you are the root user of this operating system and you have the root password, you should never log in with that password directly. You should log in with some normal user account, and only when you need special permission to do something like, for example, change important settings in a file or install a program or uninstall a program and so on, then and only then can you use this special account and then return back to your normal account. This practice will help protect your system from unintentional damage, and of course it helps set the separation that we have just talked about between system files and user files. Now let's have a look at the File System Hierarchy Standard, or in short the FHS. Now Linux has many flavors, and we have discussed flavors before in previous section, that because Linux is the name of the kernel and not the name of the operating system, several vendors and several people have created and developed their own versions of Linux, so you have several distributions or distros of Linux. But because of that, we need some sort of a standardized location for important system files and directories. Now imagine that you have a program that is designed to work on Linux, okay, and this program has an installer. You double click on this installer or you launch it from the command line, and this program is supposed to put some files in some well-known locations that the developer who created this program knows that those directories should contain or should be referenced by the system, or should be considered by the system to contain that sort of files. So for example, if the program wants to place its binary files, it may place them in /usr, just for example. If it wanted to log some information about its events and so on, it may do so in the directory that is called var, because var is the directory used by Linux generally to place different types of log files. So for that reason, the FHS, or the File System Hierarchy Standard, was developed. It just aims at defining a standard location for different types of files and folders or directories. So in order to understand the FHS, you will have to understand that it classifies files on the system according to the following criteria. We have two main types of files, those that are shareable and those that are non-shareable. Shareable files are those that could be shared across multiple systems. Think of documents, spreadsheets, presentations, audio files, image files, or any file that is created by the user, in other words, a user file. And also program binaries and scripts can be shared among multiple systems. Now, if you have a program installed in some location on your system, let's say, for example, /home/ahmad/ImageMagick, let's say I installed ImageMagick in that location, and I want to share this location with somebody else. I want to take this directory and put it on another computer that is running Linux. I can put it in the same path that I have put it here on the other system, and it should work the same way it did on my system as long as the prerequisites were availed. Okay, so a program binary can be shared normally, so it is shareable. But non-shareable files are those that contain information specific to the system. So for example, I cannot share, and I should not share, the system file that contains the IP address and the gateway information of my computer, because normally this file is specific to that machine, because as we're going to study when we delve into networks and networking, that no two machines can have the same IP on the same network. When you have a system file that contains the IP information of a machine, this file is not normally shared and should not be shared with other computers. It is specific to that machine and that OS at that time. So this is the non-shareable file type. But that's not everything. This is just a broad classification. A shareable file may be variable or non-variable, and also a non-shareable file may be variable and maybe not. A variable file is a file that tends to change either by the system or by the users. A well-known example of this type of file is the system log file. The system log file gets changed like every minute, for example, because every now and then something happens to the system and it has to log it into some sort of log file. For example, that daemon came up, or that daemon came down, or the following user has logged into the system, or the following user has failed to log into the system. He or she typed the password several times wrong, and so on. These are events that get logged to some sort of a system log file. So this file is by default changing, but being a variable file does not mean that it might be shareable or non-shareable. This is just another classification. Now, a file can be shareable and variable, and it also can be shareable and non-variable. It depends upon the type of file. The second distinction here is non-variable files. Those files that tend to be static, like for example program binaries. Now when you install a program, the binary that is used to launch this program will never change, because if it did change, that means that a new version of the program has been developed and that you will replace the old file with the new file to have access to the new features of the program. But otherwise, neither the users nor the system administrator should change this file. It's a binary file. It should stay intact. It should stay as it is in order for the program to continue working or behaving normally. A non-variable file may be shareable and may be non-shareable. Now, we said before that the program binaries can be shared across multiple machines, but we can have some other type of file that is static as well, but it cannot be shared among machines. That is, as we said, specific to that machine and that OS at that point in time. According to the FHS, a file may fall into any combination of the above categories. Now, in the coming lecture, we're going to see the most well-known directories that are defined by the FHS standard on a Linux installation, so stay tuned.